the mic. Someone should off his mic. No, it's not console. I think it's better. Please just on your mic when you want to talk or say something. If you're not saying something, you off it. Okay. So if you want to say something, you just on your mic, you say it, then make sure you mute it back. Okay, as I was telling you people, in fact, the idea of this class is to advise you people, in fact, on how to answer paper 3, because some students think that paper 3 is difficult or things like that. No, it's not as if paper 3 is difficult. It's very easy to take, because paper 3 is 30%, let us say 5% for your manual. It's very easy to take 20% in paper 3. Not because you are very intelligent to take the 20%, but simply because you are smart and you are doing what you're supposed to do. Because sometimes people stress in the exam for nothing, and even the minimum that they are looking for, we are not seeing it. You're not seeing it, and it's how people are feeling in the exam. Now, so I'm going to start with something like database. So I'm sure this is not the first time I'm saying it. Concerning database for advanced level students, you need to master ER-digram and SQL language. So this is what you need to master. Now, in addition to ER-digram and SQL, you need to master normalization, because there are some questions where they will be talking about ER-digram, they will be talking about SQL, but they ask you to work on normalized tables. So you are saying that in this case, if you don't know normalization, you are blocked. So in summary, concerning database, know how to normalize tables, know your ER-diagram, know how to write your SQL code. And concerning SQL code, it's not as if you need to know how to write everything. No. You just need to know how to insert elements in a database, how to create a database, small things like that, how to delete a database, add an element to a database, to modify a table. Modify a table simply means imagine that you create a table with 4 attributes at the beginning and they ask you to add a 5th attribute. So how to do it? So these are just the few things you need to know. It's all. The rest, anything that concerns SQL code, like this June 25, there are so many exercises there that you need to use the join operator, but it's not necessary to know how the join operator functions, because you can just use your SQL view, write your SQL code, and you still have your result. So that one is very possible and clear. Now, so as I was telling you before we move to anything, if you want to talk, I think you have the floor. Like all what I've mentioned here, if you think you are here and you have a particular problem concerning all these elements, I think we can discuss on, take an example, go through the example, and then it's okay. So who is talking?
Yes, sir.
Emmanuel, yes.
You are not seeing your computer screen.
You have not yet shared my screen. Yeah.
Okay, sir.
You have not yet shared. I'm first of all talking. It's based on what we've been doing that I will share.
Okay, sir. No problem.
Good. Concerning the different elements I've mentioned, are you okay with all these aspects?
Yes, sir.
Okay. And what about the others? If it is clear for everyone, I think the best thing we can just take, I don't know, an example we work on, and it's all. So that at least we have.
Sir.
Yeah.
Can you better explain like the second and the third number form when you're talking about transitive dependency?
Okay. She's talking about normalization. Okay. So let me share my screen. I want to share one document. Okay. Okay, so let me go to the document. Normalization. Okay, so I want to use one document so that I can be showing it with examples. Okay, is my screen visible? Is everybody seeing this document?
Yes, sir.
Okay. Now you need to understand that generally what happened in when we talk about database, we have different way of representing database. Meaning what? Now here, let me just write something. Database. We have different way of representing database. Now there's what we call a flat file database, and there's what we call a relational database. Now when you are working with a flat file database, here you are just having one table. So a flat file database, in fact, just a database consisting of one table. Whereas now a relational database is a database consisting of multiple tables related together. So now mean that there's a relationship between all the different tables. So that's the first thing that you need to know. Now, normalization is coming in to solve a problem we have with a flat file database. Now, what are some of these problems is what you're supposed to understand. If I move back to this my document, this is an example here. I'm having this table here. This is a flat file database. You see, in this table, let us say this is the database of a particular school where I'm having student information, I'm having information about subjects, I'm having information about teachers. Now, so the different problem overcome by this type of database is what we call database anomalies. So if they ask in the exam, list some database anomalies, they are just talking about the different problem overcome when we have an unnormalized table, meaning what? When we have a flat file database. And generally we have 3 of them you need to master: insertion anomaly, update anomaly, and deletion anomaly. Now insertion anomaly simply means what? It's when you are trying to add maybe an element in the database but you are forced to enter another element. For example, if I look this table here, what's the primary key? So in this table, the primary key cannot be student alone because here I'm having repeating data, and we know very well that primary key is an ID that uniquely identifies a record. So if I'm having the column student ID 101 and I'm having again 101 down here, it simply means that this column alone cannot uniquely identify a record. That is why you need to combine it with another column. So in this case, for this table, we are combining student ID and subject ID. Both together uniquely identify each record. So in this case, our primary key is what we call a composite key. Now, mean what? If you take maybe 101, you realize that 101 with subject is the first 101 here is the subject ID is bio 101, but the second is chemistry 210. So it is completely different. So it's clear that the primary key is a composite key, as I was saying. But now you realize something. Generally, when a table is having a primary key and you're adding data into that table, you cannot leave the field or maybe the different fields of your primary key empty. You must fill everything. So now adding a new subject to a table means what? That you need to add the ID of the subject name. But since the primary key of a table is not subject ID alone, but subject IDs and student ID, you are forced to enter information about student, which is a problem. So this is what we mean by insertion anomaly. Update anomaly, the same thing. Like here, you realize there is a student offering biology. So you are seeing that if you have 100 students in this table offering biology, we will repeat biology everywhere. We will repeat also the name of the teacher doing that subject. We are repeating also the name, the phone number of the teacher offering that subject. It simply means if tomorrow I want to modify maybe the phone number of the teacher teaching that subject, I'm supposed to modify in all the different records where it's occurring. And the probability of doing a mistake is very, very high. Like if you do a mistake, the data becomes not accurate again. So this is the problem that you have with update anomaly. And deletion anomaly, the same thing. Deletion anomaly, like here, if I want to delete maybe a student 101, I'm forced to delete also the subject he is offering and the teacher taking that subject in the database. So this is the problem of deletion anomaly. So the aim of normalization is to solve this problem of anomaly. So it's to reduce these anomalies. And it's not the only problem. The next problem, in fact, solved by normalization is what we call redundant data. Because here in this table, you realize you have so many redundant data. If 100 students offer biology, you repeat biology 100 times. So that is why when you are defining normalization, you are just saying that normalization is the process of organizing a database to reduce data redundancy, or you say to reduce repetition of data and some anomalies. Good. Now, and to do so now, the idea of reducing data redundancy and these anomalies is to break that flat file database into smaller subtables. So this is the idea. So when you're applying the process of normalization, this is what you're doing, dividing a table into subtables. Now, to do so now, we have different normal forms. This is what we call the first normal form, second, and third normal form. Now, what is the first normal form doing? The first normal form here is checking two things from your table. The first thing that the first normal form is checking is if your table has a primary key. This is the first thing. And in my own case, I think we have primary key. Student ID and subject ID both combined together is the primary key. So the first condition is verified. The second condition is saying that each cell should have atomic value. So you should not be having a cell in your table having multiple value. Like for example, if I'm having here biology, physics, so on and so forth. So by the time you are seeing that type of thing, it simply means that your table is not having atomic value. But in this our own case, if you look very well, each cell has atomic value. So it simply means that this table here is in first normal form. Now the next thing we are supposed to move now to second normal form. And let me just show you something. In the exam, you can have this case. I'm having one capture somewhere. Okay, so this one image I was using in my tutorial. Yeah, you can have a table like this one, where at the level of subject you see math, physics. So this cell is not containing atomic value. So either you say atomic value or you say single value. And to normalize this, you simply repeat this same record multiple times, but you write subject on different line. That is why if you look the normalized version, here I'm having 101 John Dewey math, the same 101 John Dewey but physics. So this is how we normalize it. Now, so let me close this. Now we continue with the document. Now let us go to second normal form. So what second normal form saying? The first condition with second normal form is that your table should be in first normal form. And now the second part of second normal form is that all known key field. When you say known key field, it simply means that columns that are not part of the primary key. All known key fields should depend completely on the primary key and not partially. So this is what second normal form is saying. The first information I want you to note is we can only check second normal form on a table when we have a composite primary key. If you are just having a single column as your primary key, that table automatically is in second normal form. It simply means that the next thing to check is third normal form. But now when your table is having a composite key as a primary key, then now here you can check second normal form. And second normal form is saying that all the different columns that are not part of your primary key should depend completely on the primary key, meaning that should depend on both on a different column found in your composite key at the same time. If you are having a known key field depending just on part of your primary key, it means that table is not in second normal form and you are supposed to normalize it. And normalizing here simply means dividing the table into subtables. So this is exactly what happened at this level. And generally to check it's not difficult. If you take something like student name, you realize that student name here depends on student ID. This one is very clear. And sometimes you are not even understanding the meaning of dependency. When you say dependency, it simply means, so if I say student ID depend on student, if I say student name depend on student ID, it simply means that if I know the student ID, automatically I will know the student name. So it's exactly what happens here. The same thing, class depends on student ID. It simply means that if I know the student ID, I will know the class of the person automatically. Now, the next thing, if you go here, subject name, you realize subject name is depending on subject ID, but not depending on student ID. And it's very clear because a subject has nothing to do with a student. It's not as if the school will be offering a new subject and that new subject is directly related to a particular student or something like that. No, the student depend on, the subject name depend on subject ID. Now, teacher name. Now, the teacher name here is also related to subject ID because a teacher is teaching a particular subject. Now, teacher phone is not directly related to subject ID, but it is related to teacher name, and teacher name depend on subject ID. So it simply means that all these people they are depending on subject ID. If you take the case of grade now, you realize that a grade is for a particular subject obtained by a student. So grade depend both on student ID and subject ID at the same time. So to normalize this table is just to create subtables where we are eliminating this partial dependency and we have complete dependency. So my first table here, I can call it maybe student. This is what I did something here. Having student name, class, since both depend on him, and you just fill your table. And when you are filling your table, you avoid data redundancy. So when you are filling the table student, no need to come and hide 101 adjoint meta from file and you repeat again the same 101 adjoint meta from file. No, you are now eliminating redundancy of data. The same thing for the table subject. This is what I'm doing here. For the table subject, you write all the different columns that depend on subject ID. Now for the table, for the next table, generally the next table, in fact, you can just use the name of your composite key to create that table. If in the exam they are not giving you the name, that is why the third table I'm calling it subject student, something like that. You call that table, and then in that table now you are having this and this to be your foreign key. So the combination make the primary key, and you add the column that depend completely on both. So this is how you normalize, in fact, in second normal form. So before we move to third normal form, is it okay or is a question?
Yes, sir, thank you.
Okay. Now third normal form is saying that the table should be first in second normal form and there should be no transitive dependency. So what is the meaning of transitive dependency here? Transitive dependency simply means that amongst your known key field, there should not exist a dependency between them. In fact, there are different ways of explaining that. So let me just take 2 or 3 methods to explain it and we move to the next thing. So like here, if I take the case of the table subject ID, so here I'm having subject name, teacher name, and teacher phone number. They are known key field. And if there's any dependency in between this known key field, that table is not in third normal form. And it's exactly the case. Look at something. If I take teacher phone number is not depending on student ID, on subject ID. No, teacher phone is depending both on the teacher, and it's the teacher name that depends on the subject because a teacher is teaching a particular subject. So it means that to put this table in second, and you are not supposed to have this type of thing in third normal form. No, third normal form is saying that there should not be transitive dependency. Transitive dependency simply means a column depending on a column that depends on the primary key. This is what we mean by transitive dependency. So you don't want to see that type of thing. So to solve that problem, in fact, you just create a new table for teacher. Good. And make sure that new table that you are creating is having a primary key. So that on the table subject, you just add the foreign key of the table teacher. So that we are still able to link, because we are seeing that from the table subject, here we are able to see that, okay, the subject biology is being taught by Mr. Gota. So separating the two tables into two, we still need to identify this relationship. That is why here when I'm separating, I'm having something like this: teacher ID, teacher name, teacher phone number. So remember, these two columns was at the level of the table subject. So I've just created a new column called teacher ID. I'm filling it. And now on the table subject, you maintain your subject ID, subject name, but you add down your column here, a new column, and this new column here is the foreign key of the table teacher. So that's from here when I'm reading my data. Okay, subject biology, and the foreign key is what? 1. So this one links me directly to the table of teacher, and 1 is who? Mr. Gota. So you are seeing that from here we are still reading our relationship normally. So it's exactly that with third normal form. Are we okay now?
Yes, a little bit.
When you say a little bit, what? Pardon?
Can I have another example?
Oh, it's so that I did not prepare another example, but let me just try to show you something else. Now, if I take the case, or let me just go to 2025. I think 2025 they're talking about something like that. Let me just try to see if I'm having that paper here. June 25. They're talking about third normal form. Computer science, June 25. Okay, so this is the paper. Okay, so you have something like this at the level of June 25. They say an e-commerce company wants to develop a database to manage its data. The database should store information about customer, orders, product, and suppliers. Now, so yeah, these are the different relations. So as there's something I wanted to explain, let me just go back here before I come back. Now, at the level of representation of a database, because there's one part under this chapter that we call database design. Database design. Now, generally when we are designing database, we are starting with the ER diagram. Now, after the ER diagram, we are moving on to what we call the relational model. The relational model here is what we call the implementation of database implementation. So relational model simply means this is where you are precising on the different foreign key, and from the foreign key we are able to know that okay, this table is related to this table, and so on and so on and so forth. Now from this relational model, this is what you are translating maybe to SQL when you are implementing it, or you just implement it using the database, the interface of Microsoft Access. So depending. So to implement, just know that you are using a database management system. So you can use maybe SQL language to create it and so on and so forth. So relational model here simply means that you give the name of your table, like this June 25. Oh, is that June? Like this June 25. They give the name of the table. Well, generally using this method, in fact, a table here is called a relation. Like customer, your customer is a relation. So if you read the equation and they say, given the following relations with your attribute, this and that. So relation, they're talking about name of table. So in bracket here, these different columns here, we call them attributes. Good. Now, so let us try to identify this one. You have the table customer, in bracket customer ID, name, email, address. Okay. Product ID, product name, price. Supplier ID, supplier name, address. Order, we have order date, and we have total. Now here, the first thing you need to identify, because normally when we are having this relational model, we are supposed to identify foreign keys to see the relationship between them. But you realize that when you look this table, let me take the case of a table customer. Primary key is customer ID. I'm having name, email, and address. So there's no foreign key in this table. Go the foreign key inside the primary key of another table. This one I'm assuming that everybody knows it very well. Now, product. You have product ID with the primary key of a table, product name, price. So no foreign key. It simply means that from what I'm reading here, there's no relationship between product and customer. Now you go to supplier ID, supplier name, address. So here we are seeing that there's no relationship between supplier and product or customer. The next one here is what? Order. We have order date, total. There's no foreign key here. So you realize something that there's no relationship between this table. Pardon?
Can start back explaining
how to do
those relations.
Yeah, it's what I'm okay. Let me just take an example. I think before we even move to this 2025, let me explain something. Let me go to, I want to illustrate something here. Now, generally people are used to this. In fact, let me just take this. People are used to represent table like this. Now here, let us say this is the table student. Okay, and you have something here like student ID. You have student here like name, something like that. And let me just say here age. Good. And here now you are filling your different data inside. Let us say student ID number 1, 2, 3. Here let us say the name, I have John. Here I have something like Eve. Here I have something like Jean. Okay. The age here I'm having 18. Here I'm having 19. 20. So if I use to things like this, in fact. Now, so this form of representing data is already the implementation in the database. So by the time you're having a table, this is what we call the implementation of a database. So this format, in fact, is just like visualizing your database. Like when you're in Microsoft Access, let me just open Microsoft Access. Let me just create anything here very fast. Or let me just open any database. Okay. Okay. Now, like here, when I click this table, This table we are seeing a different column, we are seeing the different data. So yeah, this already the implementation, mean that here you are just visualizing in fact your table and the data inside. Good. But when we are constructing the table, we are not really starting from here. No, we need to pass through ER diagram first. After ER diagram, you go through relational model, and from the relational model now, you know exactly who is primary key, who is foreign key, and you are now creating it in your database management system. Now, so what happened if you are having some, let me just take the case of this table. If I'm having a table like this one here, like this table, and I want to translate it to a relational model. So in a relational model, what happened is the name of a table here is what we call a relation. So in my own case, the name is what? Student. So I had student. You open your bracket, you list your different attributes. The attribute here simply represent the column of your table. So the first one here is student ID. I write student ID. Student ID is a primary key. Generally for primary key, either you underline or you just put an asterisk here. So it depends how the question will be precise. If the question doesn't precise anything, you just underline and you leave it like that. You leave it like that. Now, so the next thing here, you leave the next attribute. The next attribute for that table is what? Is name. The next attribute is what? Age, and you close. This is what we call relational format of representing a table in a database. So this is what you need to know. Now, we continue. Before coming down to this relational format, in reality what happened is we are supposed to move but from ER diagram. So we are having an ER diagram. From the ER diagram, we need to know how to interpret an ER diagram and come up with a relation. And generally what happens at the level of GC now is the reverse. Like they will give you a relational model and they will ask you to draw the ER diagram. And for you to do so, you need to understand what we call cardinalities. So let me just explain something with an example so that we are going to take past question. And you'll be seeing that when you master this, in fact, I'm not seeing which past question will be more than you. Now, generally to draw ER diagram, we have different methods. But the easiest method, in fact, is to use these symbols. Rectangle, oval, and relationship. So the first one is for rectangle, oval, relationship. So the rectangle here generally is used to represent your entity. Don't forget that entity here represents the name of your tables. Now, here the oval is used to represent your field. The field here are attributes. Good. So the column of your table. Now here the relationship in fact is just like the what relate in fact two tables together, things like that. So we are coming to this one. Now let me just take a simple example. Imagine that I'm having something like this. Let us say I'm having an entity here called student. Okay, and I'm having something here maybe called, let me just take school. Okay, here I'm having a relationship. Now let us say student here is having as attribute student IG, and you underline it because it's a primary key. Okay, let us say you're having another attribute. Let us say age. Let me just end here. Now for school, let us say here I'm having school IG, and let us say here I'm having school name. Okay, so now here there is a relationship between the two. Now, so between each relationship, because what you are supposed to understand is with an ER diagram, for us to read a relationship is through cardinalities. And the cardinalities here we have 1:1, 1:many, or many:1, meaning we have the same way of interpreting it. And the last one here is many:many. So you need to understand how each of them function. Now let me start with 1:n. Okay, now let me just say that a student, let me just take this, a student, and generally you need to know how to read it also. When you are reading cardinalities of an ER diagram, always take one entity, or let me just say, how can I say it? Always take one object of your table and you compare it now with the number of subjects in the other table. For example, here I'm going to say one student can attend only one school. And on the other side, we say one school can have many students. Are we there? Good. So this is just one calculator that's created here. So you are seeing that from this ER diagram, I'm having what? 1:many. Good. 1:1, many:1, because here is n. You are reading from left to right. So many:1. Now the question is how to translate this ER diagram now to a relational model. So this is the next thing I want to show. Now, remember that at the level of relational model, then now when you are translating, you must precise your foreign key, because it's the foreign key that shows this relationship. from the ER diagram, you are not drawing ER diagram and at the level of each table, or let me say at the level of each entity you are adding maybe, I don't know, something like an overlay right in the foreign key. No. On ER diagram, don't go on an entity and you write the primary key of another table because it's foreign key. No, you don't write relationship like that on ER diagram. Now if I go to the relational model, here the first table here is student. So student. Now student here contain what? Student ID, primary key, it contain what? Age. So let me leave it like that first. I'm coming back. Now the next table here is what? School. Contain what? School ID, contain what? School name. Now you ask yourself that, okay, among these two tables, which primary key is supposed to become foreign in the other table, and vice versa. Now please never forget it. When you're having something like 1 is to many or many is to 1, always go to the side of the table where you are having 1. That side, in fact, you take that primary key and that primary key become foreign on the sides of the table that we have n. Meaning what? On the table student, I'm going to have what? School ID, which is a foreign key. So here I'm going to have school ID. Good. And general school foreign key have been represented with an hashtag beside like this. So take note of this. And on the table school, you are not adding something here because the table school, in fact, is where you're having 1. So when you're having 1, you're not adding something there. Now let us take an example for you to understand this very well. So if I take something like, let me just take an example, because this is what happened. Now with example, you understand how it works. Meaning what? If I take, or let me just go back to my table. Okay, let me just take an example down here. So it means what? Let us say I'm having a table student. This student here. This is the table student. And we say we have student ID, which is the primary key. We say we have the age of the student. And here we say that we are having our school ID. Okay. So let us say here I'm having 3 students. Student 1, 2, 3. Okay, the age, let me just say 20, 19, 15. Now for the school ID, I will fill that one is a foreign key. Let me just draw the table school first. Now let us say I'm having the table school, something like this, with 2 school inside. So here school ID, and here maybe school name. Okay, let us say I'm having school ID number 1, school ID number 2. Okay, let us say the first one here is maybe GS is source, and the other one is maybe GS Mimboman. Okay, I'm having 2 schools like this. Now remember that when a table is having a primary key, it simply means that each record of that field must be unique. Good. So in the table student here, who is primary key? Student. In the table school, who is primary key? School ID. And here we are saying that the table student should take what? School ID as foreign key. And when a table is already taking a foreign key, simply means that here you can have repeated data. Like I can have something like school 1 here, and I have again school 1 here, and here maybe school 2. It's possible to repeat like this because this column here is a foreign key. So on the level of foreign key, it's possible that you repeat data. Just make sure that what the data that you are writing here must exist in the other table where the field is primary. So like I cannot come and write school 3 here where school 3 is not existing here. In this case, the data is not more accurate. So I'm able to do something like that. And what's the interpretation of this? When I'm doing something like this simply means that school 1 is having student 1, and this same school 1 is having what? Student 2. So you are seeing that from here, we are seeing that one school is having how many students here? So one school is having many students. So and it's exactly this interpretation we had here. You said one school have n students. So one school have many students. And the reverse is not true. A school, and here what are we saying? That a student can attend only one school. Imagine that you were doing the reverse, like in the table school, you added maybe student ID there. Good. So doing that simply means that you are saying that, okay, since this student ID is a foreign here, so I can maybe take the ID of student 1 and write 1, 1. It's what you are saying. And if you are writing something like that, it simply means what? That one student is attending how many schools? 2 schools. So here you are seeing that one student can attend many schools, whereas in this cardinality is not what has been precise here. From here we are seeing that a student should attend just one school. So that's why I was saying that generally when you're having something like 1 is to n or n is to 1, go on the side of the table where you have 1, you take that primary key, you go and put it foreign key on the side of the table where you have n. So this is how you are retaining it. So the example under here was just to illustrate for you to get why are we doing that. So I don't know if this is a question.
Yes, I think the example was really correct and want to be more efficient. So can you go back to the June 25?
Yeah, I'm going back now to June 25. So it's whether before going to June 25, we are not done. So yeah, I'm just talking about 1 is to many. Now the next thing that you need to note also is 1 is to 1. So for 1 is to 1, the same reasoning. When you're having something like this and there's one on the left part, one on the right part, what happens is the side where you're having one on the left part, you take that primary key, you're going to put it foreign on the other side. And the same way, the other side where you have one, you take also the primary key, you're going to put it foreign on the other side. So 1 is to 1 simply means that when you be translating your two relations, in fact, you have the foreign key of each. Now, the last part here is what? N is to N. So generally, when you're having N is to N on both sides, it simply means that you create, in fact, your relationship will become a new table. Like here, let us say my relationship is at 10. It means that you have something like that with at 10. So it is the case of N is to N. You have something like this at 10. And here, this at 10, we have the primary key of each of the different tables is related with. Like here, so you have here student ID, comma, and school ID. So good. By the time you have seen an intermediate table with two primary keys, or let me just say two foreign keys, it simply means that when you are drawing your ER diagram, that table is at the middle of the two, and the cardinality is N is to N. So this is what you need to note concerning things like that. Good. So and in the exam, I repeat again, in the exam you'll be having the relational model and you are the one moving to the ER diagram. And if you don't know this interpretation, it's very clear that you will not really convert that to ER diagram. So we go back now to 2025. So before this, is it okay here for everyone?
Yes, sir.
What about the others?
Yes, sir, it's okay.
Okay. Now, if you go back now to 2025, the first problem now at the level of the relation, because there's someone that asked me to explain this relation. So I was explaining this cardinality to come back here. Now, so here we are realizing that we have the table customer having his primary key, correct? Now, but if you analyze very well the other field, there's no foreign key. So product, the same thing, there's no foreign key. Supplier ID, supplier, there's no foreign key, only primary key. Now order. In the table order, you realize that here we only have what? Order, date, and total. No other information. So it's not having any foreign key, no primary key. Good. And when you're already seeing something like normal, you're supposed to have an idea of what this table is. But now, generally, this is what I'm telling my students. In the exam, it's not as if you are supposed to create something or whatsoever. No. Always read your question from start to end. So after reading this table, because if you read these tables, let me say this relation, and you limit yourself here, you want to answer this tax 1 on this first question on a tax 1, it's impossible. Impossible because here they're asking you to, in your answer booklet, they're asking you to produce an ER diagram in third normal form. Underline key field therein. Good. And you are seeing that there's no relationship between them. If there's no relationship between them, it's as if you're drawing each single table and you're not going to relate them. So that's why always read all the questions to understand exactly what they are talking about. And if you look very well under here, we have some tables. Good. Like here, I'm having the table customer. So customer, I'm having customer ID, customer name, email, correct. But if you look at the table product ID, you realize that product ID is having a foreign key here, supplier ID. It means that in the exam, you take your half work paper, in fact, and you rewrite this. Like you rewrite this relationship now, adding the foreign key. So that is what you'll be using now to draw your ER diagram. Meaning what? If I'm taking the case of, let me just try to write here. Let me just take. A minute, let me just take this case and answer it so that you see what happens here. Because this 2025 year, the student was supposed to reason some more about the question. Open with Microsoft Edge. Okay, I think my screen is still visible. Okay, so you are seeing that here. Okay, the table customer is not having a problem. So here we have customer is not having a problem. Here we have customer ID, no problem. Customer name, okay, email and address. Okay, no problem. Now the next table here is the table product. So the table product here, we have product ID, comma, okay, underline the primary key is better. Product ID, you have product name, you have supplier ID. Okay, supplier ID here is a foreign key, so you put an hashtag beside like this. Good. Here we have price. Okay, now we continue. The next table under here, I'm having the table supplier itself. So supplier, I'm having the table supplier with supplier name, supplier ID first, sorry, supplier name and the address, okay, of the supplier. Now if you look very well under, you see that you have the table order, and the table order is having order ID, okay, customer ID, and customer ID here is the foreign key. We are clear with that. Good. The next thing here we have order date. Now it's so that this here they did a small mistake in the sense that if you go back to your different relation, you'll be seeing that here we have order date and we have total. We have order date and we have total. It means that here, let me just add the total and I will indicate the next mistake again on this here. So here total. Okay, so this one we are having. Now you realize that okay, the table order is having customer ID, meaning what? That order is related with the table customer. So there's a relationship between them when you draw your ER diagram. Now the next thing that you observe is okay, that product is having supplier ID. So it means that the table product is related with what? Supplier. Now, but if you are drawing this ER diagram, you'll be having two tables. In fact, you'll be having two separate parts of your database, like the part where customer is connected to order and the part where product is connected to supplier ID. So saying that in fact supplier is not connected to any order, any customer, the same thing, product is not connected to any customer, and so on and so forth. But you realize this is a problem, because if a customer is passing an order, that order is about a particular product. So this means that normally there's supposed to be a relation between product and order. So this is exactly what happened. Now let me go back to this in fact so that you get it well. You realize that the table order is having what? Order date. So now here you're supposed to reason. Order date here simply means what? That the date on which a customer ordered a product. So you are seeing that here this attribute here, order date, is depending on both the customer and the product. So just to tell you that in the table, at the level of the table order, here we are supposed to have a field product ID, which is also a foreign key. So that when you be drawing your ER diagram, the table order is supposed to be in between customer and product, because here the relationship is end-to-end relationship. Meaning that if I'm drawing this ER diagram, let me just draw it somewhere here. If I draw it somewhere here, I'm going to have the table customer. Okay, here I'm going to have the table product. Okay, now here the customer place an order. Okay, what happened? You draw something like that, you draw something like that, and the cardinality here is n is to n. Meaning a customer can place the order of many products, and a product also can be ordered by many customers. And here, when a customer order a product, we have an attribute here concerning what? The date he ordered the product. So order date, and it's not all. We have also the total number of product ordered. So it means that here also we have what? We have total. Good. So you are seeing that here, I'm not going to move at the level of order and add another line here, write maybe customer ID, write maybe order ID. No, we are not doing that here. By the time you are translating to ER diagram, you are not drawing any arrow, in fact, with a particular oval to indicate a foreign key. No, because the aim of the cardinality is to read the relationship between tables. But in the form of ER diagram now, in the form of relational model, to read the cardinality, we need to precise the foreign key. So this is what happens here. And from what and from this relationship, okay, here we saw that supplier now was linked to what? To product. It means that here you have a table supplier somewhere down here, supplier, good, link to product. So there's a relationship between product and supplier. And what is the relation? You go and you analyze it, exactly what I was explaining. So here you will realize that on the table product, you have supplier ID, which is the foreign key, and on the table supplier there is no foreign key there. Now, so you realize that the primary key of the table supplier is foreign on the table product. And from what I've explained before, I told you that if a table we take his primary key to put it foreign in another table, it simply means that on this side of the table on your ER diagram you're supposed to have 1, and the other side where you are putting it to be foreign key you must have n. So it simply means that here at the level of supply I'm supposed to have 1 here, and at the level of product I'm supposed to have n, because it's the supplier ID that is primary in the table product. And from here now you can try to read maybe a supplier supply one supplier, or let me just say a supplier supply n product, and a product is just and the product is obtained just from one supplier. So you just read it like that and you respect what the equation says. So yeah, I can just use maybe the keyword supply, okay, something like that. And now you draw. Now concerning the different oval and the attribute, you try to look what you have up here. Now, so yeah, at the level of what you are having up here, there is no foreign key. So, and it's very clear because on your ER diagram you are not supposed to have a foreign key. It's clear. So here you come and say customer ID, name, email, address. It's exactly what you are writing here at the level of the table customer. So you just draw your different line, you draw your oval, you write inside, and so on and so forth. The same thing for order. Order we have what? Order date and total. Okay, we did that already. You just go and you adjust these two. Now for supplier, you go supplier ID, supplier name, address, product ID, product name, and so on and so forth. Because the mistake some students are doing sometimes is when they are drawing this at the level of a particular table, they draw over the height of foreign key in there. No, cardinality is saying all this. I don't know if there's a question. Is it okay?
Yes, it's okay.
Good. What about the others?
So I have to ask a small question.
Okay, ask your question.
Why is it that you did not create a fit table?
The fit table for which fit table?
Since there's a many relationship between customer and product.
Yes, of course. But yeah, there's a many relationship between customer and product, and that table exists already. Now the table is called order. Are you not seeing the table?
Okay.
That's why you are seeing that in total here we are having 4. Where is it? I count very well. 1, 2, 3, and 4. So order is between customer and what? And product. Are you getting it now?
Yes. I thought that we were to create another table. So
No, the table has been created already for you. That's why I was telling you. Now listen well what we are doing. What happened is, it's not as if the GCE board is giving you the ER diagram to go to the relational model. No. They are giving you by the relational model and they are asking you to move back to the ER diagram. And you are supposed to have this interpretation in mind for you to come up with something like this.
yes, sir.
Is it okay?
Yes, sir. So I have an issue.
Yes.
So I think because to identify the primary key and the foreign key, I've understood everything explained there.
Yeah.
The problem is to identify the foreign key and the primary key.
Okay. So what is the problem?
So how do I know that this is the primary key and this is the foreign key?
It's exactly what I said. A foreign key, the foreign key of a table should be the primary key of another table. For example, when you see the table product, you see here product ID, product name, supplier ID. Supplier ID is the primary key of the table what? Supplier. It simply means that in the table product, this supplier ID is but the foreign key. It's a foreign key. And the aim of this foreign key is just to link, in fact, a product to its supplier. Are you getting it now? Like for example, let us say you are in the table product and they ask you the name of the supplier that supply caps. How to know the names? If there's no foreign key here, it's not possible to know the name. So since there's a foreign key, I know that okay, those supplying cap, okay, supplier ID is what? Is 1. So supplier ID is 1 and it is linked to the table supplier. Where is 1 on the table supplier? This is 1 here. So from here we are seeing that okay, the supplier name is who? Is Usman. Are you getting that? This is what we call relationship. That is why generally when you are creating foreign key, don't come on the colon foreign key, you maybe enter a particular data that is not existing on the table where it is primary. For example, the table supplier, you have seen that here we have 4 suppliers. There's nothing as 5 here. So don't come where it is supplier ID is foreign and you write 5. There is no more making sense. It's as if you are entering a data that is not existing. Are we there? Okay. So who else is okay with this part? And with what I've explained here, I'm not seeing any, because I think the last time I was going through past question with some student like that, and with this explanation, in fact, you cannot be having a problem drawing ER diagram again. It's not possible. So from what I've explained here, you can just try it, so that if you have a problem, you just send it in a group. Let me explain it back. But you should not have any problem. June 24, June 23, 22, 21, there's no problem there. Good. So just tell that you must have this rename, because go up, go down, you see a question on, you see similar question like this. These are the asked question in the exam. So I've explained that normal form. And now let us go. The question say, let me just wait there. They say in your answer booklet, produce an ER diagram in that normal form. So now, generally when you're having this relational model, let us check for that normal form. Now you remember that for us to check for that normal form, we need to check for second normal form. And second normal form is saying that non-key fields will depend completely on the primary key. Now let us analyze the table customer. The table customer, we have customer ID, which is the primary key. And the last time, what did I tell you? Now by the time a table is having just a single column as primary key, automatically the table is in second normal form, because you cannot have partial dependency. Partial dependency means your primary key is composite and maybe a field can depend on part. But in our own case, we are seeing clearly here that we have a single primary key. The only table that have 2 primary keys, or that have a composite key here, is the table order, where the primary key is what the composite key, product ID and customer ID. Good. But you should check now very well if it's in second normal form. Order date. Is order date depending only on customer ID, or is order date depending only on product ID, on both? And it's clear that it depends on both, because the order date here inside is the date by which a customer ordered a product. So it's depending on both customer and product ID. Total, the same thing. Here we are talking about the total of a product ordered by a customer. So yes, the total depends also on both product ID and customer ID. Are you okay? Good. So you are saying the table is in second normal form. Now let us check third normal form. Third normal form now is to verify if there is any transitive dependency. Transitive dependency, as I was explaining, among the non-key field. Take note, the definition is saying that among the non-key field. When they say non-key field, it simply means that if there is any foreign key there, it is not included. It is not included. Non-key field, like the case of customer. The table customer, we have customer ID. Now the non-key field are what? Customer name, email, and address. And we are seeing that all these data are related to customer ID. There is no like a dependency between each of them. No. Like you never say that email depend on customer name. It's not making sense. It's not making sense. The same thing. You are not going to say that address depend on customer name. It's not making sense. So take note of things like that. Then if you go to the table product, we have what? Product name and price. Subject ID is a foreign key, so you cannot say that it's a non-key field. Good. So here we have product name and price, and product name and price both depend on product ID. It's okay. But now between product name and price, is there any partial dependency here? No. Is there any dependency? Sorry. No, there's no dependency, because you cannot say that a price depends on product name. Saying that price depends on product name is as if you are saying that if I know a product name, I will know its price directly. But it's not the case, because you can know maybe a product name like caps, and the price is maybe 2,500. But we can have another product with that same price, in fact. So you cannot be saying that the price depends on product name. No, because for a single price, in fact, multiple products can have that same price. So that's why on this table it is already in that normal form. So there's nothing like to separate here. And if you go down to order, the table order is very clear here, that between order date and total, you cannot be saying that total depends on order date or total. So there's nothing to divide here. So that's why for third normal form, generally when you think that there is a dependency between the non-key field, try to see if there's dependency, can you divide this table into 2 parts and create a foreign key, like what we did for the table. If I go back to this my document, if I go back to the note under normalization, yeah, So you are seeing that here, for me to divide this table, like this one in fact, for me to divide the table, subject to create a table subject, to create a table subject alone and a table teacher, it's simply because here there was a real transitive dependency. Like here we had teacher phone number depending on teacher name without depending on subject, and it was very easy that here I can really divide this table to create a table teacher having only information about teachers, and we use a foreign key to link it. In fact, like what we did here, we use a foreign key to link it to the table subject, so that from the table subject you are still able to know the name of a teacher teaching a particular subject. I don't know if it's okay now. Good. So you are seeing that from this table they are already in third normal form. Are you there? Good. So yeah, this year there was like nothing to do like breaking it again to create new table. No, we're just supposed to draw it directly. So as I was telling you, make sure you do so. Now concerning SQL query, like the second, yes, a question. Yes.
For that, for the entity order,
for the ER-digram,
for the entity order, the primary key is still order ID.
For the entity order, what is order? Oh, no. I told you that there was a mistake here. The primary key is product ID, customer ID, both combined together. Are you getting that? The primary key is a composite key.
This means that order ID is not supposed to be included there.
Exactly.
But in the exam, can we remove that column?
Yes, you can remove it in the exam.
Okay, sir.
And the next thing I wanted to mention, also my next advice is, in the exam, don't be having a question and you are blocked on something. You just leave it like that. No. If you think that there's something blocking you and you can correct it to move, correct it can move in fact. Don't stay blocked somewhere, because generally you are marking in fact what you are doing. So when we are taking, because at the end when you finish writing your exam like that, they will print all this work. So if at the end we have nothing to print for you, then when they are marking, you just need to assume that okay, he did nothing and he just cross everything and move. So always try to see that okay, if something blocks you, you correct, you move.
Yes, sir.
Good. So these are things work there, so that you have something to print at the end.
Okay, sir.
Good. So now we go to the next. The next here is what? SQL. Now concerning SQL, it's so that I will not be writing SQL code here for you, because I'm assuming that normally everybody should know how. I think on my website I'm having a document there showing all the different SQL query you need to know. So on the website, I think everybody knows this website, schoolforall.com, this website. So generally when you're at the level of the website, just go to notes. When you're on note, you choose your level, advanced level. If you are doing computer science, you click on computer science, and here these are the different chapters available here. Good. So you just download what you need and you work on it. So majority of this PDF I'm using in videos, I'm putting it here. Hope it's okay.
Here's a question.
Yeah.
So you see, the thing is not easy to assimilate because there are many things you have to know now. So I want to ask if it is possible to get back the live as a video.
Yeah. I'm always posting it online. You get it back online.
Okay, sir.
It's a replay. That's why as I'm doing something like this, the main idea is like tomorrow, take other past question. Like today we did database, take other past question and you answer question on that. So that if there's any problem, you come back. Because if you are doing like that, also you keep your notebook, you just go and I don't know. There's no more time, you see. So when you learn something, you go and practice directly. Just like we don't really have time to. But I'm already telling you that you will not have problem with other questions, because when I'm looking even this database of this June 25, it was a little bit difficult compared to past years. So there's no problem here. Now the next question, let us go to the next question. The next question here is say, but I'm not really solving this, I'm just guiding you. Write SQL query that will enable you to add the column phone number to the table. Now, is everybody here know how to create SQL tables? Create tables in SQL? Yes, sir. Perfect. So generally you just have something like create table you give the table name. If the table is called student, you give student, you open, then you list your attributes here. Now, when you list the name of an attribute, let us say there's something like student ID, you list student ID, you give the data type. It is varchar, you hide varchar. And remember that when you're using varchar, you always precise the size. Then beside there's no comma, you precise your condition. If this is the primary key, you hide the primary key. Good. And you hide comma, you do the next, and so on and so forth. Good. And the last attribute here, you don't put any comma, you leave it like that, you just come and close under with a semicolon. So just know that this is the syntax of writing SQL for Microsoft Access. That is why sometimes I'm telling my students, don't just go on, I don't know, on ChatGPT and type that, show me this SQL, show me this SQL. No, it's not generally working like that. Because he can give you an answer, but maybe the SQL code that he's giving you is to work maybe on another database management system. Like, let me just take the case of Oracle, or maybe the case of this thing, how they call it again, DBeaver and things like that. Things that people don't know. You see, good. What people are using in advanced level as database management system is Microsoft Access. So you must write your SQL code with a syntax that works with that. In fact, good. And this is what I'm showing here. Just to tell you that there are different ways of writing SQL code, not just one way, but we follow the syntax that works with the software we'll be using at the level of the GC. Good. So this is for create table here. So now, make sure you know how to create table. Now the next thing I wanted to precise, please, you need to know also how to add relations. Meaning what? When you create a table, if in your table there is a field, let us say here I'm having a field, I don't know, something like customer ID, and this customer ID may be varchar. Okay, let us say this customer ID field is the foreign key of another table. So it simply means what? That after listing all the different attributes of the table you are creating, at the level of the last line you write what? You write foreign key. Foreign key, you precise the key that is foreign here. What do you say? Customer. Okay, customer ID. Then you write references. You give now the name of the table where this foreign key is primary. If the table is maybe called customer, you write customer, and you put in bracket, you precise the name of that primary key in the table customer. If it's still customer ID, you write customer ID. Good. Why are we doing so? Because you can create a table, and in that your table you're having a field foreign key, and that foreign key now is the primary key of another table, but you are using the different names to do so. Like here, I can hide club, I can hide customer ID in full in the table, in my table where it is foreign. But in the table where it is primary key, customer ID is not being written in full, but it's just written something like cost ID. So how to go through? Because another student will think that no, there is a mistake. Like going to say that why is that in the table primary key it is cost ID, but in the table where it is foreign key they write customer ID in full. It's not a mistake. If you see the type of thing, it's not mistake. It simply means that when you be writing your SQL, you take that into consideration. If you're on a table, maybe I don't know, a particular table where it's cost like this, foreign key, you write foreign key, you write the name used in the table where it is foreign. When you write references, customer, in bracket you write by the name now used in the table where it is primary. Are you people getting what I'm saying here? Good. So take note of things.
Please, I'm not understanding.
Pardon?
I'm not understanding.
Do you know how to create table first of all using SQL?
Yes, sir.
Do you know how to add a foreign key to a table in SQL?
No, sir.
Why? There's a document on a platform. This is what I'm saying here. If you create a particular table, but you go to the document, if you create a table like this, let us say I'm creating create table, and let us say the table is called student. Okay. Let us say that on the table student I'm having maybe student IG. Okay. You would write what you need to write here. Let us say here you are having this subject ID. Okay. Let us say it is varchar. Okay. And that now on the table subject, the primary key there is maybe called subject ID in full like this. Good. But you are seeing that on the table student they are writing but sub ID, not subject ID in full. Now when you are creating your foreign key, this is what happens. You write after listing all the different attributes. Generally you are writing this at the bottom. You write foreign key. You give the name of the foreign key in the current table where you are. In that table it is called subject ID. like this, using this same abbreviation. Now you write references, you give the name of the table where it is, primary, that table is called subject. Here you write subject. In bracket, you're writing down the name of the primary key, because you know that a foreign key must reference a primary key. So, and the primary key is what? Subject ID. Good. So that is why we always precise. And I'm saying that here we are always precising again the key in bracket of the table, because they know that in the other table the name can be different. It's so that it can be the same, like it can be different. You can fall on a situation where it is different, like this situation here. And a student can think that it's a mistake, like they will ask themselves that, okay, why that is subject ID, but here it's sub ID, thinking that it's a mistake. Well, it's not any mistake. Is it okay now?
Yes, sir.
Then you close it like that. Now the next thing I want to precise is like this 2024. Yes, what came in 2024. There you realize that when you are creating your table using SQL code, you are not supposed to add this, because, and the next thing, because some students are doing things without understanding. Remember that when you are creating SQL table indicating foreign keys, what you are precising here is you are already creating a relationship between the table. Meaning what? Meaning that when you be at the level of Microsoft Access, when you go to database tool relationship, you realize that the relationship will appear automatically. Like this line here will appear automatically. So when you are precising foreign keys at the level of SQL, you are already creating the relationship automatically. But if you don't precise the foreign key, like here, let us say subject ID is a foreign key, but you don't come under and say foreign key, reference, blah, 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 you don't write it. If you don't write it, it simply means that when you come to Microsoft Access after, you realize that your table will appear at the level of relationship, but without these lines, So you'll be the one now to add the relationship manually, as you know. I think you will know this other method, in fact, of adding, of creating a relationship. Are you okay? Are you okay?
Yes, sir.
Good. And now let me come back to the case of that June 2024. In June 2024, there you cannot really create the tables by, what is it? You cannot really create a different table and precise foreign key references, this and so on and so forth. Why? Because when you try to answer June 24, you realize that all the relations that you are having there have foreign keys. So, and normally for you to create a foreign key, like for you to precise a foreign key by saying foreign key references this, they put the name of the table here. The name of the table where you are trying to reference must exist already in your database. Meaning if you have not yet created this table, it's not possible for you to precise foreign key. Like let me just open that paper of June 24 so that you see what I'm saying. 2024, I think I have the paper here. Okay, so this is the year 2024. This is what happens here. This year they have three relations. They have the relation match player, the relation player, sorry. They have the relation player. Wait, I want to open it using, let me open it using Chrome. Using Fire, using Edge. Okay. So let me use this pen and illustrate. Okay, here we have the relation player, we have the relation club, and we have the relation coach. That's why I'm saying that play, you should answer past question. This June 24 is similar to 2020, I think it's 2022, almost the same thing. So when you're used to answer past question, I'm not sure you'll be having problem at the level of the DC. Now, try to analyze your relation. So the table that we are having online is just a table describing the it's just a table describing your attribute, like the data type of attribute and some example of data when you be filling it. Now, if you go at the level of the table player, you realize that okay, here we have player ID primary key with the star, because the question said that the asterisk here represent the primary key. So player ID here is my primary key. Now club ID, you are seeing that here club ID is a foreign key because there is a table called club with club ID as primary key. So you are seeing that here we have a foreign key. Now there's a relationship between them. Now you go to the table club. It simply means that when you are creating your SQL query, you cannot come under and say foreign key club ID references club. No, because the table club has not yet been created. So it means that you stop creating player, you go and create first what? Club. But now when you're in the table club, you realize that there's coach ID, and coach ID is also a foreign key of the table what? Of the table coach. So it simply means that this one also you cannot create the SQL query by precising the foreign key, because precising the foreign key simply means that you reference what? coach, to precise coach ID, where the table coach is not existing. Okay, let us say you just pause this one, you go and create a table coach first before you come back. But now coming to coach, you realize something on the table coach. That here you have what? Club ID, foreign key. Meaning if you want to precise the foreign key when you are creating this using SQL, you must first of all create a table club, or it was not possible to create a table club because of code. So you are seeing that here you have foreign key everywhere. So when you are creating your SQL query, so there's no place where you go and say foreign key reference is this. No, you will not do so. You just create it naturally by precising the primary key. And after now to create relationship, you just come back at the level of database tool relationship. A small window will appear. I think everybody know that windows. In fact, everybody know that window. You click on that window and you add a different table. You create a relationship manually. Are you understanding? Are we getting it?
Yes, sir.
Yeah. So please take note of things like that, because I'm saying that because in the exam, some people will come here to create query design. The person will go to SQL view, and while writing his SQL, he will be precising that thing of foreign key. At the end, he's realizing that nothing is working and the person is blocked, not knowing what is happening. Take note of things like that. When you precise a foreign key, you reference a table. That table must exist already. If the table is not existing, it's not possible. There's someone near the mic. Okay. Are you okay now?
Sir,
Yes.
can we not first of all create maybe the table coach without the foreign key, and after we go and create the table club with while including the foreign key, and after that we can go and alter the table coach while adding the foreign key in the alter command.
Exactly, but you are seeing it's long. You are wasting time for nothing on something that you create manually after. It's not necessary.
But on my answer sheet, I can write that code now for them to give me all my marks.
No, they will give you all your marks. No need to precise it. No need to precise foreign key. No. They will give you all your marks. I think it was 2 marks. Yeah, it was 2 marks. Yeah, it was 2 marks. No, they will give you all your marks. When the GC board is doing like that, they know what they are doing. In fact, they know that you create relationship after. Just that some students will fail in the sense that they will not really know that they are supposed to create relationship after before doing queries. Are you getting the point?
Yes, sir.
Okay, it's exactly that. So it's not as if you are to precise in the SQL query. No. It's not necessary. It's not necessary because questions are always linked. Meaning what? At the end of all what you are doing here, there's a question where they will ask you to write a query. And you cannot do a query if your tables are not related together. So the GC board doesn't care how you are relating it. No. They don't really care if you are relating it using the data tools view or you are creating your relation when you are creating your table. They don't care about that one. They are not looking at it in fact. Good. Now, the only thing that if the GC board precise that while creating table, precise foreign key. Now in this case, now we must precise the foreign key by saying foreign key J reference is this. But when the GC board is not precise in that line, it's not necessary. You just create normally. No need to precise. You create it normally here at the level of database 2. Are you getting it?
Yes, sir.
Good. So don't stress yourself in the exam. Are you okay? Any question or we move to the next? I think it's okay.
Yes, sir.
Question 3. They say use a suitable database management system of your choice to implement the database design in one above. Good. So they're asking us to implement what you did at the level of the ER diagram. Because at the level of ER diagram, you are showing in fact all the different tables of your database, relationship, and so on and so forth. Now, so you see that this here also did not complicate with this question. They do not precise that write SQL code to create a table. No. So you see me now, for you to implement that database design in one above, you can do it manually also. Like you can just come to database, create, you go to table, you come and click design view, and you add it normally. You give the name of the table, you add things normally. So, but if you think that no, you are very fast when you are creating but queries, fine, you're going to create queries there and you do it with it. Are we okay?
Yes, sir.
Good. And to create query now with this one also is not difficult, because if you analyze very well, what is that thing? Good. To create query here will be very easy, right? Because the table customer is not having any foreign key, so you create the table customer naturally. Now the next thing here, you have the table product. The table product is linked to supplier. So after creating customer, create supplier. So always start creating table that are not having foreign key. Now when you are creating the table product, you create it normally. If you want, you come and precise at the level of your SQL query that supplier ID is a foreign key. If you don't want to do so, you do it after at the level of relations. The same thing with other ID. You can create other ID normally without precising anything. Good. But if you think that you want to precise that, okay, foreign key, product ID, references, product, because the table product has been created already. Product, you put product ID, then fine. The same thing with customer. So at this level, you are the one, you just choose what you want to do and you do it. Are you okay?
Yes, sir.
Okay. So this same year, if I go to the next question, question 4, they say insert sample data into database created and print a copy. Now this thing of inserting sample data, because sometimes when I'm supervising, I'm seeing a student taking his time to enter data. No. In the exam, don't even think the data that they are entering there is completely fake. So anything that passes to your mind when your hand is on the keyboard, you just type it and you move. So now the question is, what is the idea behind this question where they are asking people to insert data? The idea is just to verify that you people master what we call referential integrity. Referential integrity simply means what? The DC board wants to be sure that you will not go maybe on a table where you have a foreign key and you add maybe a particular value that is not existing on the table where it is primary. Are you getting it?
Yes, sir.
So that's the idea of asking you to fill table. Like, yeah, and generally for this 25 was even easy because you're already having tables here with data. So you are just recopying what you are seeing here. And when you are recopying, it's not as if you must copy it exactly, because I repeat again, students will be wasting time for nothing. Don't waste time. Customer ID, just write direct. The name, even if you do any mistake, spelling mistake, don't care, just pass in fact, because we are not checking it in fact. What we are checking is your referential integrity. This is where they are testing, because they didn't know that some students, they are not even aware of this thing of referential integrity. So you'll be seeing someone's feeling. But as I will tell you, this 25 is very easy because you're already having the data. For June 2024, where is it? June 2024 is not the case. June 2024, I think there's question 3, question 5, something like that. No, 3. Yeah, they say for each table in your database, add 5 rows of data consistent with your column entry. And you're seeing that if you look this year, there's no table with data for you. So you are the one to raise it and fill. The only thing that they help this year is by giving you some example of data. Like here on the table, maybe player. They're saying that example of player ID. Since player ID is of type text, meaning varchar. And the next thing also is when you are translating this, text here means you'll be using varchar. Good. There are some SQL, there are some database management system that accept text also, but Microsoft Access, we are using with varchar there. So don't go on your blog. The same thing where you are seeing number is int. Now what happened is short in here is small in. I even did a video where I'm answering this 2025 database. That's why I don't want to waste time here. So if you have any problem with this here, you watch that video where I'm answering it. It's already on YouTube since 1 month today. Good. Long in here, you just write in. Meaning that when you're creating your SQL query, for long in, you just write in like this. For short in, you write small in like this. And for text here, you write varchar. And varchar is always taking the size in bracket. That is why you are seeing that on the table they are giving you the size. Like for player ID, they say size is 6, so you write 6, comma, and so on and so forth. Now here, this is what I wanted to show you. That here they are just giving you an example of how the primary key should look like. Example of how club ID should look like. Now, don't go in the exam and you take this example, you want to develop yours. No. Meaning what? When you be filling, for example, the table player, at the level of player ID, since they are telling you that you are supposed to have something like this, like 21A001. So just make sure that for the first player ID, you have your 21A001. The second one, you have a 21A002, 003, 4, and so on and so forth. So generally, at the level of your data, just try to look one entity, or let me say one part that you'll be changing, because some students will be like saying that, okay, now saying yes 21A001, let me write B00, and so no. If you are changing so many things already, you are wasting time in the exam. You cannot be fast. Now the same thing here with club ID. Example here they say Barca 001. Don't go in the exam, you start thinking about club that okay, no, my second club now will be Real 001. The second will be, I don't know, Liverpool 0. No, don't think about club. Just take this Barca 001 and your second club, you name it as Barca 002, Barca 003, Barca 0, and it's okay. You leave it like that. You leave it like that, because don't go, you start thinking about club in the exam because you want to feel, no, you are wasting time. Because this question, I think, is 2 marks or something like that. Yeah, it's just 2 marks. Where is it? This question was for it is 3 marks. Yeah, so you are seeing that 3 marks to fill all these 3 tables is not really something. So don't waste your time. And another advantage of having a particular nomenclature when you are filling your data is not for nothing. Why? Because the table, the column on club ID is foreign and his primary way in the table club ID. So you are seeing that when you are using a particular nomenclature, it becomes easy also when you be filling what the table club. Because when you be filling the table club, the other interface is no more open for you to see what you did there. So you need to recall, in fact, all what you did on the other side so that you write it here. So that you don't come here maybe and you have your different club ID and you maybe forget a club ID that you mentioned at the level of this other table. In that case, it's not more working because the other table club ID is foreign key. It means that anything that you are writing here as your club ID must exist here in the table club as club ID. That's why I'm saying that having nomenclature that you know that okay, you recopy it here without even thinking in the exam. Are you okay?
Yes, sir.
So this is the advice concerning this thing of filling data. Take note of that, please. Because some people, you're wasting time. You see, you are supervising, you pass in front of someone. After 5 minutes, you pass again, the person is doing the same thing. After 10 minutes, the person, you are just surprised that. So take note of things like that. Take note of things like that. If you go now to the next question of 2025.
Please ask a question.
Yes.
When you're asked to populate a table using SQL code,
Yes.
to insert in 3 different rows, things Microsoft Access cannot allow you to insert 3 rows at a time.
Perfect.
How are we supposed to go about that?
Exactly. You just recopy. Like when you write the first SQL code, you clean it, you write second value and so on. Your question is very nice and interesting. So people should know that, please. When you are inserting, normally the keyword is what? Insert. Let me write it here. Insert into. You give the table name. Let us say the table name is student. Then you go to the next line. You write values. In bracket, you list now the different values here. And remember that here, normally after insert into table, you are supposed to have a particular bracket where you are indicating the different column of your tables here, the different attribute of your table before saying values. But generally, no need to do so. No need to do so because when you are inserting your value in the order in which the attribute has been precised in your entity, then no need to precise it. Generally, you are precising this bracket when you are changing the order. Let us say maybe the first thing was student ID. But you want to enter student ID maybe at position 3. In that case, this bracket now is important for you to precise exactly which position you'll be using to fill. But I'm not seeing why you must change position. So good. If the first thing is student ID, name and age, write your value, you write your student ID, comma, you write your age, and so on. The next thing also, anything voucher, when you're writing it using this method, you write it in double quotation mark, like double quote. Good. Anything integer, no code, you just write it. If there's any integer, you just write it like that naturally, and so on and so forth. Now when you are done, you clean this. No need to even clean all. You just clean the value part, this, and you rewrite the new values for the second row. Because some student, I'm getting your point. Some student will come again after writing this value, you write another value in. Do this, write another value to fill. No. You do one by one. You save it. One by one. You save it. Good. And this is the case of Microsoft Access. Other relational database model, they are accepting that you should enter multiple values at the same time. But Access is not refusing, it's not accepting that. And this is the problem I'm having with some students that are going on ChatGPT to make their research and it's not working. Forgetting that they are giving them a general result. And they are not aware that you're supposed to even to precise which relational model, which database management system they are using. So yeah, your question is nice. Is it okay?
Yes, sir. But in the case where you have asked to screenshot you have been asked to show proof that you created each SQL code, populated using SQL code. It's not just insert the values like that. Since I'm going to delete these values and write back new ones, which proof am I having to show that I actually wrote
No,
the
no.
code?
If they are asking proof of SQL, generally you'll be having space on your paper to write it. Generally, if there's no space on your paper to write, they will ask you maybe to make a screen capture and put it in a particular document to print after. These are the two cases there. Are you there?
Okay. Yes, sir.
Good. So either you have space on your paper where you'll be writing the query, or they will just ask you to make it. I think everybody know how to make screen capture. So when you go there, for example, let us say you're writing your query here. With that thing, create. Good. So when you're at the level of SQL view, they can ask you to make by the screen capture. So screen capture, generally what happens here is there's a button print screen on your keyboard. So generally it's beside F12 like that. When you just click there now, it's going to make a screen capture automatically. You open a Word document and you paste it there. Good. Yeah, I'm using Windows 11. That's why when I press there, it's asking me to select the portion I want to screen capture. But on Windows 10, it's not generally asking it. You just press on that button and it captures the whole screen. You go and put it there. Good. So it's exactly what happened. Or maybe what they can ask, like what they did for the ICT student, is they can ask you to copy the SQL code and go and paste it in your Word document. At the end, they will print. This is what they did for the ICT student. So, are you okay?
Yes, sir.
Good. The majority of the time for computer science, I'm just seeing space for you to write. So, question 5, what are they saying here? They say, okay, I think yes, this other one, I think everybody know how to do this. Write queries that will enable you to add phone number to the customer table. Good. And description to the table product. So here, which command? What the SQL code that you're using here to add something? Like after creating a table and you want to add a new attribute, you're using what?
Alter.
Very good. So you just use alter table name. After writing your table name, you come and write what? At. You don't list your different things. Now here you can alter many fields at the same time. You add, you give the name, you give the data type, comma. If there's another thing, you add and so on. If there's no other thing, you just go to the next and so on. Okay, so if you have any problem here, I have documents showing SQL codes. So nice. So now, if you go to question 5, what are they saying in question 5? Implement SQL query to perform the following operation and then copy them into their respective spaces below. Okay. A, retrieve the name of all customers who have placed an order. Now, let me explain this, please. Here, as I was telling you, you will be using the design zero. The design zero. Okay, the design zero. Create query. Query design. You select all your tables, you just add them. Good. And before doing this, I repeat again, you must have created relationship in advance. Like when you're at this level, we must see this relationship between your table before you make a query. Why the relationship important? Because there are some query that you'll be doing and data are coming from different tables. By the time a query is already taking into consideration more than one table, if there is no relationship between the two tables, the data that you'll be obtaining will be wrong automatically. Good. Now, query becomes useless, relationship becomes useless when maybe you are doing, I don't know, you are just trying to query a data on a single table. Then it's fine. Now let us go to this one. The first question, they say implement SQL query to perform the following operation and then copy. Okay. A, retrieve names of all customers. Good. So customers here, there's a table customer with names who have placed an order. Now, how to do so? Let me just assume that these are my different table here. Why that table? Okay. Now, I think let me just clean this thing, please. Let me clean this for us to see what we are doing. How to increase the size of this gun. It's taking time. I don't know how to increase the size here. Okay, let me just limit myself here. Okay, now, so how to do so? They say name of, let me just go back and read it. Okay, I'm already on the paper. They say retrieve name of all customers who have placed an order. So you are seeing that here there's a relationship between what? Customers and orders. So how to do so? Good. Now, to do this, because this is where some students are doing mistake. Like you see a student coming to the customer table. The first thing, when you go to the customer table, you double tap on what? On name. I think everybody know how to do so. Like when you're here, let us say buyer at the customer table, you just double tap and the thing appears down here. So this is what you would do for what? You would do it for customer name. But now they say customer name who place order. So where is the table order? The table order is down here. And on the table order, there's a foreign key here, customer ID. And if you are seeing a customer ID on the table order, it simply means that these are the user who placed an order. So it simply means what? That you go to your table order and you double tap on customer ID. You double tap on customer ID. So let us assume that this is my table order here and customer ID is maybe buyer ID. I will double tap there. So when you double tap there, now you are sure that here that the different IDs here correspond to users who order we ordered something in fact. Now, but the question did not ask you to display the order ID and the customer name. No. What am I saying? The question did not ask you to display the customer ID and the customer name. So you just go and you uncheck in fact customer ID, so that when you run this query, only the names in fact of those having your customer ID will appear there. So this is what is happening here, because some student here, they just come and click customer name and just run it like that. So if you just double tap on customer name and you run it like that, you obtain in fact the name of all these customers with all these IDs. Or this is not what we want. So it means that go on the table customer, on the table order, you double tap also on customer ID, so that it will be a filter in fact among these IDs here. Then after doing that, you go to SQL view, you copy your SQL code, you write it here. Are we okay? Any question?
Yes, sir. Yes, sir.
Okay, we go to the next. So B, they say retrieve the names of all the products that Jane supplied. Use join operator to obtain your answer. Good. As I was saying, you don't need to know how to use the join operator. Good for your level. So generally, when you reach university, that then now is obligatory, because in university we are no more working with Microsoft Access. No, there you'll be having a normal course like database design, where you are writing queries directly on the papers and things. So there is obligatory. But in advanced level, sometimes students find it a little bit complicated. That's why I don't waste my time teaching it. Now, so yeah, retrieve names of all products that Jane supplied. So you are seeing that here, two tables are coming in, the table product and the table what? Supplier. So you take note of these first two things. Now you go, it simply means what? That on your table product, because they say name, or they say retrieve all names of all the product. So you mean on the table product, you double tap on product names first. Good. Now they say name of all product that Jane, with it, that Jane supplied. Now that Jane supply, you go, you make a small analysis. You go to the table supplier, and the table supplier, you realize that Jane here is a wait, let me just say it a bit. That Jane supplied. No, Jane here is the customer. Okay, so this is it here. This is it here. Now on the table customer, you realize that here we have Jane here is ID. Okay, this Jane ID 002, and here we have again, there is no mistake in this table, because here I'm seeing Jane Fu and I'm seeing again Jane Fu, maybe different ID, as if it's different customer. Or let us assume there's two different people. Let us say yeah, where you're having this Jane Fu, it's just Jane. Because when I'm even seeing the email address, you see that here is Jane@gmail, where the other is Fu@gmail. So it's only the same mistake, because here we are seeing different customer ID and we are seeing the same name. So it's not possible to have, it's just a mistake at the level of the data. So if I don't care about this thing. So let us come back. This is what I was trying to say. They say retrieve all names of product that Jane supplied. So you are seeing that Jane here is a customer and product is here. So you just need to know the relationship between the table a table product name, and a table customer ID. Now, are we having a relationship between them? Yes, we have a relationship, and that relationship is from the table what? From the table order. From the table order. Because it's the only way you can know, in fact, that okay, this person supplied this and this person supplied this. So to do so, this is what will happen. Remember that where you are having this order ID, we are supposed to have it what? We are supposed to have a supplier. We are supposed to have a product ID. Sorry. Yeah, you are supposed to have product ID. It simply means that for us to know, in fact, the name of those who supply, not the name of those who supply, but the name of product supplied by Jane. So it means that yeah, you come here and you double tap on product ID on the table order, you double tap on customer ID. See the first thing that you are doing. Now, after doing this, you are already having a relationship between them. Now you go to the table product, you double tap on name, and you go to the table customer. Now for the table customer name, there it depends on you. You don't even need to double tap. You can just identify Jane. Jane here is what? 00002. It simply means that yeah, at the level of criteria, you just go and write equals to 00002. So that yeah, we are just going to display exactly the product name of the customer 002. Are you getting it? Hello?
Yes, sir.
The others are sleeping. Are you forgetting?
Yes, sir. Yes, sir.
Good. So take note of things like that. When they are already asking you data coming from different tables, try to see a relationship between them. Relationship. Because see, as I was telling you, there is no relationship between product and the table customer and the table product directly. No. But the relationship between customer and product is order. So you make sure that on this table you double tap to have product ID, you double tap to have what? Customer ID. And Jane here now is 002. So you got a level of criteria, you equals to 00002. Then you add now the column what? You add the column product name. Good. Seeing the column product ID is already there, it simply means that the ID in fact of a particular product name, when you display that, in fact you have the name. So you just make sure that you just go and uncheck. You uncheck that product ID, so that product ID should not appear, but just the name. Take note of that. So if you go down to the next question here we have what? After they say print a copy of your query. So in the exam, when they say print a copy of your query, it simply means if you are at the level of what is that thing? Query design. Sorry. You are at the level of this SQL view. When you say print a copy, make sure that you are at this level. You just click on File, Print. Okay. Yeah, we cannot print this interface here. You cannot print this interface. Okay, let me just read by the question. It's as if I did a mistake. They say print a copy of each query. Now, yeah, this question is not as if it's ambiguous. It's not ambiguous. It's not ambiguous because for the SQL query, you are writing it on the paper. So here, when they say print a copy of each query, they are asking about the result obtained after the execution. Like when you execute this, in fact, what's the result that will appear? Is that result, in fact, that you are printing? And that result generally will appear in this tabular form, like this. And when it appears in this tabular form, now you can now click on File, Print, and make sure that here is PDF selected. You click on OK, and you save it in your candidate folder. Are you okay? Because here some students can think that maybe they are supposed to print, but this interface here, no. Because if you check very well, it's not possible to print it. Good. That's why they're asking you to write it on paper. So the question is not ambiguous. You are printing but the result of the query. Now, is it okay there? Are we okay? Okay, if you are okay now, we move to the next thing. The last question here. If I go to the last question they say retrieve the names of all customers who have ordered a product supplied by Usman. The same thing. It's very easy. They say retrieve the name of all customers. So you see how many tables are involved here. The table customer ordered by, so the table ordered must be present by Usman, and Usman here is on the table what? The table supplier. Now yeah, it depends completely on you. Now what happened for this query is, it's very clear. They say retrieve the name of all customers. So customer name, you must double type. The customer name is already there. There's no problem. Now after having customer name, you go to the table of order. You click on customer ID, so that we are sure that the customer name that we appear is first of all those who did a particular order. So you go to the table of order, you double tap customer ID. Good. So after doing so, now continuation of the question, they say name of all customer who have ordered a product supplied by Usman. Good. Remember that the table ordered is having customer ID, but it's not having supplier ID. So where is supplier ID? Supplier ID is related to what? It's related to product. Good. So you have seen that here. Now for you to have the product of the supplier ID precise here, you must go back at the level of table order. You double tap also on product ID, so that when you come on the table product and click maybe on supplier ID here, it is related directly to the product ID for a particular order. Good. Now and they say that the supplied by Usman. Now Usman here, you are the one saying. So Usman here, you just go to the table supplier. Usman is supplier ID number what? Number 1. So it simply means no need to add again the colon supplier name and you go to criteria and say equals to Usman. No need in fact. If you know that Usman is supplier ID number 1, it simply means that yeah, on the table product, when you double tap on this supplier ID, just write 1. Just write equals to 1 on the, and automatically it's just going to display the name of those who order that product. So the relationship here is clear. So the relationship is from here to here, from customer ID, from supplier ID, sorry, we need to know the different product supplied of Usman first of all. And here we are seeing that this is Usman here. So Usman is supplying what? Product ID 001 and 002. Now among what he's supplying, we need to know those who order this product, and for us to know those who order this product, we need to include what? Product ID and customer ID of the table what? Of the table ordered, because here this is where we are having a relationship of those who order something, and so on and so forth. Good. So after doing so, now what happened? The next thing here is and when you include this, in fact these two tables, you realize that at the level of product ID you have what? You have 1. Product ID you have 1, and that one here is 001. So it simply means that the product in fact ordered by Usman with the name of, sorry, okay, let me check something. Okay, let me come back here. So let me just start back. So the different products supplied by Usman is 001 and 002. Okay, 001 and 002. Okay, if you go to product ID, you'll be realizing that okay, people have ordered these 2 products supplied by Usman. But the question says the name of customers. Good. So the name of customers here, surely you'll be having what? 00, customer 001 and customer 002, because customer 001 ordered this first product 001, customer 002 ordered this product. So it's exactly what happened. So you mean that you must include these 2 columns. So now after including this column, now you go to the table customer, you include customer name, so that the name that will appear is exactly corresponding to the ID precise here, and it's exactly that. Good. And the next thing why I was saying that this other ID is product ID is because in database generally when you enter something like 001, automatically you will bring it to 1. Good. Having something like 001 simply means that you are the data type here is a text, and surely you use with what? Integer. If you're using integer, you write 001 is bringing it to 1. So don't think it's different, it's the same thing. Are you okay? We are done with this question.
Yes, sir.
Good. Then you copy your query and you put it here. So it's a little bit that. So I don't know if there's any other question. If there's no question, so this, I think we did almost everything concerning database. I'm not sure there's a concept I missed out. I was talking about SQL query. I was talking about SQL query and SQL code also. How to create table, modify, delete, and so on and so forth. And ER diagram. Good. And also normalization. So we covered everything in this class. So tomorrow what we have to do now is under programming. So programming, I'll be explaining the different concepts you need to know. Programming, you need to master how to manipulate arrays, very important, two-dimensional arrays, one-dimensional arrays. Good. The next thing also in programming is you cannot work without writing sub-programs. When I'm talking about sub-programs, they can be function or procedures. You must master it. Now, and the next thing is that programming is not difficult, but by the time you don't even know how to translate a pseudocode into a program, this is where you are blocked. Because generally programming question, they will describe everything for you. They are describing it, you are just executing. They are giving you the algorithm, you are just executing. And if you are not able to execute, this is where problems start. That is why generally when I'm doing tutorial on data on programming, because on my YouTube channel I think I've answered June 24, 25, 23 concerning programming, and I'm focusing in fact on how you are supposed to answer a question in the exam, things like that. It's not about your program must work completely. No. Just the fact that you are writing, you are translating the program, you have marks for that. The fact that now you are executing a program and obtain that black screen, you have a mark for that. Because obtaining that black screen simply means there's no syntax error in your program. And when there's no syntax error, you have marks again for that. Now, it's after that now we check now the output in fact, because you can have no syntax error but there are semantic error, meaning that maybe the logic of your program somewhere it's not really correct. That is why you have that black screen, but the output that we are seeing here is not what we are expecting. In this case now, you just lost the mark just for that output, and generally the mark of output after 26 marks can be maybe 3, 4, 5 marks like that. So just to tell you that you can have a programming question on 26 marks and you find yourself with 20 marks and your program is not working. So just to tell you that the important part is not like the code must work automatically, but your problem must like you need to know how to translate a pseudocode into a program, how to read pseudocode. And in all the different videos I'm doing on programming is what I'm showing there. That's why I was insisting that you should look all these things. And I was also insisting because programming is not something that you answer one pass here and you are safe. No, it's not working like that. You can answer something and tomorrow they bring another concept. And the aim also of answering past questions is to see in fact how things varies. If you answer maybe June 24 and June 25, it's not the same thing. The logic is the same, the principle, the approach that they are trying to bring in question, in the style of question is the same, but the way of implementing two different things. There's a lot of concepts they included in June 24. Like in June 24, they included structures, they included pointers, they included structure mixed with pointers, they included modular programming, meaning writing program on different files. They only on that June 24. Whereas in June 25, there's almost nothing there. There the only similarity with June 24 is the fact that okay, you can manipulate two-dimensional arrays, things like that. That is similarity there. Good. And June 23 was also very easy. June 23 just a matter of having a small logic in programming and you just translate, execute some few things. But brief, as I was saying, all these things they are not difficult. You just need the explanation. By the time you don't have the explanation, you would think that it's difficult. That one is clear and normal. I know it very well. So I'm just doing my best to explain it to you people. So you just need to follow also, because if you're not working, things will not work. So as we are done for database for today, make sure you practice past years. Go and practice 2024. We are done with 2025. Practice 2024. Practice 2023, 22, and you end at 21, because the idea is to practice from that interval 21 to 25, and from there for me you at least you enter in a GC with a small confidence in you. Because you don't have confidence in you, this is another problem, a very big problem in fact. Like even if a question is easy, you do not really feel it because you don't even have confidence in you. For you, it's like you cannot. So it's very important to have that confidence. That's why I'm just always trying to do things, in fact, the most simplest way I can. No need to complicate something here. No need. I was even taking this case like in programming. Imagine that in programming you have a code where you are supposed to calculate the square root of a number before using that result to do something. If you don't know the function to calculate square root in C programming, don't be blocked there. You calculate it manually with your calculator and you just fix the value in the variable that you need. You continue working. So don't stress yourself with small things that will block you. When you don't know something and you can turn that, just turn it and you move to the next. Another example, let us say they are asking you to use a function called round to round maybe a particular value up or down, or let us say to round down a particular decimal value. If you don't know how to use, maybe because you use function around, square root and all these things, you must include the library math.h. But if you don't know it, you don't stress yourself. At least you know that if you're having a decimal number and you take that decimal number, you store in a variable of integer, the decimal part will disappear automatically. It's going to hand it down. So you just use that method and you just move, in fact. So in the exam, take note of all these things. So okay. Is there any question? Before we stop the meet? I'm not getting you. Wow, I'm not even getting you. I don't know what's the problem.